So today we're going to do Pythagorean theorem of Converse, and this is our way of classifying triangles. So let's say we have a triangle, and the converse. I want to know if these two legs, this one's A, this one's B, if these two legs form a right triangle with this number over here. Do they form a right triangle? If they do, then I know that C squared equals A squared plus B squared. Now C is my longest side. It's always the biggest number. It's the longest side or the biggest number in a group of three. It is the biggest number. Okay? So if it's an acute triangle, C squared is going to be less. C squared is going to be less than A squared plus B squared. And how do you know which one's A or B? It doesn't matter. They're the two shortest sides. They're the two smaller numbers in your list of numbers. Now, if it's an obtuse triangle, then C squared is going to be greater than A squared plus B squared. Now, how do we know if a triangle is formed at all? Well, let's see. It says first determine if three side lengths could form a triangle. Recall from earlier, the sum of two smaller sides must be greater than the third side. So for a triangle to exist, the two smaller sides, A plus B, must be greater than C. Now remember, C is your longest side. So this is what I'm going to do. I'm always going to label my longest side C. I'm going to go through number 1 and 2 and label my longest side C. So 9 is C and number 1. And number 2, my longest side is 29. That's my C. So first, I'm going to see if this is a triangle. And I'm going to do it in brown. So I'm going to say A plus B greater than C. Is this true? So is 3 plus 7 greater than 9? Is this true? Yes. If this is true, then this is a triangle. Now I need to find out what type of triangle. So that's part B. So I'm going to sit up and I'm going to say C squared. And I need to figure out which equality I have. Is it equal to, less than, or greater than A squared plus B squared? A squared plus B squared. So C squared is 9 squared, question mark. Can't see that question mark that I'm making right there. I'm going to do it in red. I don't know if this is greater than, less than, or equal to. A squared is 3, so 3 squared plus D is 7 squared. I have 81, question mark. 9 plus 49. Okay, so it looks like 81 is greater than A squared plus B squared, because 9 plus 49 is 58. It's greater than, so that makes this an obtuse triangle. So I'm going to check it off. It's obtuse. This is a triangle and it's obtuse. So let's do number 2. Alright, we're just going to label the sides here. This is A, this is B. Alright? So first, let's see if it's a triangle. So remember I did this in brown before. I'm testing to see if it's a triangle. So I'm going to use the formula. Is A plus B greater than C? If it is, then this is a triangle and I can keep going. So it's 20 plus 21 greater than 29. I get 41, and this is true. Okay? Now, what type of equality do I have here? Question mark. A squared plus B squared. Okay, I'll plug these numbers in. 29 squared, question mark. 20 squared plus 21 squared. So this is 400. This is 441 over here. And over here, 29 squared. $841. Is this greater than, equal to, or less than? Let's see, 400 plus 441 is 841. So this is an equality. This is an equality. If I look back up there, that means that this is a right triangle. So I'm going to check off right triangle. So what I'm going to need you to do, label your numbers. Your biggest one is always C. Then you're going to check whether or not this is a triangle. So write down. This are the things you need to do. Label the numbers. The biggest is always C. Number 2. Number 2, label numbers. Biggest one's always C. Number 2, see if the numbers make a triangle. Number 3, test the Converse theorem. Test the Converse theorem. So just check to see which inequality works. Okay? So go ahead and do the rest of the page. It's good practice. It'll help you on